My name is Ejimofo Agbo. I'll be talking on the single trip completions, tubing perforated completions that we carried out in one of our wells. Okay, basically to give a brief, the presentation objective is to talk about how we're able to collapse multiple runs, conventional runs, into one simple run to perforate about 280 feet of oil well, and the advantages that you get in collapsing those multiple runs into one single run, and how we're able to successfully complete the well. Just a bit of overview about the asset. OML 24 is an asset owned by New Cross EP, which is a subsidiary of Panoshan in the group. It's jointly owned with NNPC. It's in the swamp terrain, about 162 square kilometer hectares acreage. About 3 fields. It just has 3 fields. You have the Kulama, the Awuba, and the Awuba Northwest. In Kulama, you have about 40 wells. Awuba, I have about 9 wells, and Awuba Northwest, you have 1 well. So the asset was acquired in 2014. So in Awuba Northwest, which is the field we are going to be discussing, there was only 1 well that was drilled by the former owner. So a decision was made to go in and drill a new well, an appraisal well, and in 2018, the well was drilled to about 13,000 feet TVD, and 62 degrees deviation. It was 2-hole section. We passed through 2 major faults, not a bit of an issue. We encountered 4 new hydrocarbon bearing sands coupled to the 4 that was seen in the first well, which was Awuba 1 Northwest 1. And we carried out our normal regular case tool formation evaluation coupled with the mud logging and the logging while drilling logging. And when we did that, we were able to draw inferences basically to pick up our perforation. We said we're going to drain, make sure we have a good drain for the reservoirs that were not drained in the first well, which is Awuba Northwest 1. Ensure we have a good standoff, and above everything, to make sure that we have a zonal isolation. When we carried out the case tool formation log in one of the sands, which is the B6 sand, we were able to we carry out the correlation between the top of the sand from Awuba Northwest 1 and that of 2. We also correlated the GOC, the OWC, and the base of the sand. We were able to see that we saw it 23 feet stratigically higher in the, like what we saw in the first well. And when we went further to select the perforation intervals, given a good standoff from the GOC and the OWC. And when looking at this log, this showed us that we had a good cement in this section, so we decided to basically complete these 2 sands as these 2 perforations are 2 different sands, even though they are from the same sand unit, which will give us opportunity to isolate the deeper sand, either produce the 2 of them together or isolate when the bottom one starts making water. The next sand we looked into was the C100 sand. That was seen 30 feet stratigically higher than what was seen in the first well. And we decided also to be able to drain the sections that were not drained in the first well. So in this C100, we had about 4 perforation units that we planned to perforate. So with that, we know that water will basically start coming from the bottom. So the plan was to complete the 2 of them, to complete all of them as 1 unit. And if we have issues of water, we can also squeeze out with cement. And again, because we didn't have good cement like we had in the B6, so we decided to complete all as one reservoir unit. So a challenge was put up where we had a long section of sand that we needed to perforate, and we had to deal with it. And this was a kind of a table of the panel. We have the B6, we had about 40 feet to perforate. The B6B had about 110 feet to perforate. And the C1, we had about 170 feet to perforate. That's a total of 280 feet. And if you look at the inclination, we had inclination of rising up to 62 degrees. That's a steep. That's a bit scary for some people. But it was a challenge that we were convinced we could take on. 62 degrees is scary. Okay, just a bit of theory. Perforation is basically punching a hole through the cement, through the casing into the reservoir, just to make sure you have access in and out of your reservoir. Of course, it can be conveyed using either slick line or wire line. Now, based on the complexity that we had, which is the fact that we had a long stretch to perforate, we wanted to make sure that we perforate the exact point. We had 6 different lobes that we were going to perforate. 62 degrees, dog-leg severity. We had the limitations of the gun being able to be conveyed on wireline, because at 62 degrees, most wireline companies will sound a bit shaky. So the only other option, and of course the increased cost, that's a big one. So the only other option is to go using tubing perforation. So now a bit of theory again. Tubing perforation is just basically carrying out the perforation using drill pipe or tubing. Now with tubing, it gives you the flexibility, the strength, the ability to combine your depths and all. So it gives you a bit of more flexibility that the wireline might not give you, especially when you're talking of strength and all. So the only option was tubing. Now, okay, a question came in a peer group. We have 6 lobes. We are dead sure we are going with tubing. Why can't we hit it all in one run? And of course, the first answer will be no. It's not possible. It's never been done. But thinking about it, if it's never been done, doesn't mean it's not possible. And we thought about it. We looked through went back to the drawing board, and we decided to say, okay, what do we intend to achieve going the one trip system? First of all, is we want to be precise, to hit it, get it right the first time. We want to be able to deploy it, considering the whole geometry and the whole mechanism and all. It's going to be a long stretch, 280 feet in one run. It's going to be one trip. And you want a possibility that when you perforate, you'll be able to pump through. And of course, cost. So these are the things that we put up as our panel, just to make sure that we score, like a scorecard. And when that was sure, we went, okay, let's go ahead and design the system. So we're in the 9 and 5/8 section. It's going to be 7-inch gun. We went with the deep penetrating gun because we're going to carry out any sand control. We phased it to 45 degrees. The perforation length was about 51 inches, and entrance hole of 0.3. The shots per foot, the density was about 12. And the firing mechanism, because it's a one trip, you can't afford to use the drawbar. So we decided to use, of course, we're going to use the hydraulic firing system. And we put, in order to make sure that we don't make mistakes, or you have a backup. So we had two delay firing heads. You have the primary and the backup. We made sure that the calculations were on point. Then, of course, the temperature, you had to select a gun that is going to be stable at downhole conditions. Then the shock wave, we made sure we had shock absorbers in the system. And again, we decided to remove the normal conventional packers that you set when you're doing your TCP because of the long stretch. So the shock will be transmitted through the whole pipe. And when we're done with the whole design, we went ahead to do the calculation. I'm not going to bore you with the maths, but here are the numbers. We have for the firing heads, we have our 15 pins. We did all the pressure ratings, and when we were good with the calculations, went ahead to be able to design the gun assembly. So on the bottom of the gun assembly, you have the bull plug, which is basically your guide and allows you entry as you're running in hole. Then you have your firing heads, which is the primary firing heads. Like I told you, it's meant to delay 6 to 7 minutes delay once you activate. We have the backup firing heads. It's important to know that the pins, the two things that will cause you to have a failure in the firing heads will be your pins. If you don't have a good quality check on your pins, and also if your calculations are wrong. So we did a kind of an SIT to ensure that the pins were rated to what they were rated to. So the bottom, that's the bottom gun assembly. Now it's also important to know if we had taken a good look at the table, you see that in the long stretch of the perforation, they had a long stretch of pipe space between the pipes. And since we're going one trip system, something has to take that space. So we decided to, rather than going the convention of using blank guns, which will increase the cost, we went with drill pipes. So with drill pipes, the next question is you have to be sure with your space out. So we virtually spaced out in the office, in the base, then quote unquote hand carried it to the location. So that's the bottom assembly. Then on top of it, you have all the drill pipe and the hydraulic head. Now the drill pipe is spacing the two lengths of guns. So the drill pipe has to be of the exact length. Because the key thing, if you remember the scorecard, the key thing was the precision. So the drill pipe has to be. So we had to get pre-measured drill pipes, knew the length, measured it out, and spaced it out well. So the next assembly, you have the potted sub, which enables communication across the whole assembly. You have the guns. So the whole guns, let me not bore you with this, but it's just pretty much guns, space out, the tandems, and everything. So we even had to use pop joints. Drill pipe pop joints, and they were to make sure everything was on depth. We put just 1 minute. Don't want to. Okay, so just basically gun assembly until you get to a very important point, which is where is it? It's running to. Oh. No, that's not the end. Okay, that's the balance isolation tool, which is basically helps you ensure that there's no debris that falls on your firing head. But this is the part I wanted to point out, the array sub, to make sure that we are sure we're on depth. We put a radioactive sub on top of the top shot. So what we did was we pre-measured the length between the radioactive marker to the top shot to be able to run in a while and position it on depth to make sure we are cock shot. So we don't want to run in all and misfire. Okay, so and you have again you have drill pipe all the way to surface. So the whole assembly was picked up, made up, good handling on the rig floor, good communication. Everybody knew what they were doing, and we ran in hole with normal standard speed, slowly. It was self-filling, so we didn't need to break circulation. So we got to depth, we rigged up the wire line to the running hole position, and was so correct that we only moved 1 foot. That is at 11,000 feet. So it was really what I would call an A job, running in hole. We only moved 1 foot, picked it up 1 foot, positioned the gun there, and we pressure up. Of course, pressure tested the line offline, pressured up to 3,100 psi, held it for a minute, and bled off. And you started waiting. That's the point where you wait to say if you're going to call somebody or if you're going to maybe pop a champagne on the rig floor. We had to wait for 6 minutes for the delay firing head. And you know, if you're being on a job and you know what it means to wait for 6 minutes, that 6 minutes looked like 1 hour because you don't know if it's going to come or if you have to pull out of hole. And just at the dot of 6 minutes, I can tell you, in most jobs I've been to 11,000 feet, you might not get a bang. 62 degrees, you might not get a bang. But we counted it, it was 6 solid bangs. And drill pipe vibrations. It was a celebration on the rig floor. Everybody was happy. And immediately we had a quick brine. We started losing brine to the formation. We lost up to, if you check the brine loss graph that I have here, almost up to 180 barrels. We had to start, we cut down the weight. Remember, this was an appraisal well. So we had to cut down the weight. We had to even get to the point where we had to pump the LCM peel to basically get it under control rate. And when we were on control, we pulled out of hole, and that's the picture of the guns. All shots, all holes. And at that point, we said, okay, you know what? Let's take it further, just to make sure that we're on depth, and we perforated where we wanted to perforate. So we went further to do a PLT, and from the look of the deflections, it's clear here, but it's not clear here. So if you want a quality check, you can come here to clear. Okay, but the temperature log shows a deflection just about the perforation interval. So everything was on depth. We're happy, and we also did inject injectivity into the reservoir just to do a back calculation, and these are the SIP plots that we got, and some of the data that we have. We weren't able to carry out the PLT log on the C has 4 lobes and the B has 2 lobes. So we weren't able to carry out because there were debris. So we had to come out and continue running in hole to do completions. So conclusion. It's a novel thing that has been done. Most people pretty much 2-3 zones in one run, and we did 6. And I can say after this, a couple of other companies have actually thought about it, and they have done a couple of, I think one company did 4, so it's something that is interesting. Okay, we're able to collapse 15 wireline runs into one run. Most of the perforations were 40 feet, 70 feet. Maximum wireline can carry in a 7-inch gun is maybe 25. Maybe if they want to push it. 27:30. So it's, when we did a check, it was about 15 wireline runs, where we collapsed it in one run. The TCP would have been pretty much maybe 4 runs, conventional. We collapsed it in one run. Then, of course, what everybody wants to hear, how much? We're able to save roughly about $700,000. None in my pocket yet. And of course, the one-trip system will allow you to have a good well control and well stability, because if after we perforated, because it was depleted and we started losing, we would have issue with pumping. But with the drill pipe in hole, we were able to pump. At this point, I want to thank my family, the management of New Cross and NMPC, my department, which is the petroleum, because they always challenge you. If you're in the PED department, you know that you always get challenged because they actually challenged me to be able to rise up to that. And of course, Spark Oil, which are the guys that carried out the TCP. Thank you.